the 5 different cases that we considered in or we discussed in last videos, we are going to use those 5 cases to discuss lens maker's formula. Now, why the name is like lens maker's formula? The reason is that this formula is used by those people who make lenses. How to construct lens of a particular focal length. So to know that or to get that, they generally use this lens maker's formula. Okay. Now, suppose here we considered a convex lens. Now remember, a convex lens generally it has two convex surfaces, this one and this one. If the curvature of both these surfaces are same, then in that case we say that it is a equiconvex lens. Equiconvex means both the surfaces are of same curvature. If we say biconvex, generally biconvex means both the surfaces are convex. Okay. Anyways, here we considered a convex lens. Generally we consider biconvex means this is one, if this is one surface, it is a part of one sphere. That sphere is having a center somewhere here, suppose C1. Again, this surface if you consider, then that is also a part of a sphere. This sphere is having a center somewhere here, we name it as C2. So we have two centers of curvature, C1 and C2. Now here there is a object, we placed an object, this one is the object, right? From this object, light ray, it falls on this surface S1. S1 means this surface and S2 means this surface. So from this O, light ray comes and it falls in surface S1. Now see, if this is a rarer medium of refractive index mu1, this lens is a denser medium of refractive index how much? Mu2. So refraction is taking place from denser from rarer to denser medium, and what is the shape of it? Convex shape. So we will use which formula? Convex surface where refraction was taking place from rarer to denser medium. Okay, for S1 surface we will use that formula. Now see, this light ray, you just see the diagram, you have to understand it how we have drawn it. This is the ray which falls on surface S1. Now for S1, which one is the center of curvature? C1. So which one will be the normal? We have to draw one dotted line from C1. This is the dotted line which is drawn from C1. The name is N1, suppose. The N1 is a normal. For which surface? For S1 surface. Now the light ray is moving from rarer to denser medium. So inside the lens, the light ray should go towards the normal from rarer to denser. So the light ray will bend little bit like this. This part. It will bend like this. Okay. This part. Fine. Now what happened is, suppose when we are considering S1 surface, suppose S2 surface is absent. There is no S2 surface. So if you extend it, it looks like this, no? This one, then like this. So this is a denser, this medium is a denser medium. Now if the second surface is absent, then where will be the position of image? See, this light ray bends little bit, and then what happen, if you extend it, it meets at I1. So I1 is the position of image when the surface S2 is absent. Okay, we are assuming it. And this I1, where will be the position of it? Is it in rarer medium or in denser medium? Because see, when we are not considering S2 surface, the lens is like this. This is the curvature and it will extend till this, like this. So I1 is inside the denser medium. That's what we are assuming. Okay. Now, as soon as we consider the existence of surface S2, suppose S2 is also there. So if S2 is there, what will happen? Again refraction will take place. This light ray, it will reach to this position, and for S2 this is the normal. This N2 is the normal for S2. Then light ray is moving from denser to rarer medium this time. So where will it go? It will move, it will go away from the normal. So away from the normal means if this is the normal, then it is going away from the normal, and finally the image is formed at I. So I is the actual position of image, because in reality we have both the surfaces. Since it is a lens, we have S1 surface, we have S2 surface also. So when both the surfaces are present, where is the image? The image is at I. So I is the actual position of image, but I1 is what? It is the virtual position of image that we are assuming when surface S2 is absent. So we can think it in this way: when S2 surface is in existence, then I1 is behaving like object for S2 surface and its final image is formed at I. Remember, when S1 surface we considered object is O, image is only S1 we are considering, image is I1. When S2 surface we are considering, that means we are considering the whole lens, then where we are getting the image? At I. So image for S2 surface, I is the image, then where is the object? I1 is the object. Okay, I think it is clear. Now I1, where did we consider the position of I1? As I already told you, I1 is in denser medium. We are assuming I1 is in denser medium. But finally, where is the position of I? I is again in rarer medium. So in S1 surface, refraction is taking place from rarer medium to denser medium. In S2 surfaces, refraction is taking place from denser medium to rarer medium, because I1 is the imaginary position of image when only S1 surface was present. As soon as S2 we introduced, I1 will become the object for it. And where was the position of I1? It was in denser medium. And final image, which is I, that is obtained in rarer medium. Okay, so you see this one nicely. If you still have any confusion, you can ask. So now we will move to the derivation part. This is the diagram. Some more, okay, one more thing is there. See, the object is at O, so this is the object distance U from this point, from the midpoint, from the pole. Then this is the final image I, so final image means it is V, and I1 is a considered position of image when only one surface was present. So I1, the distance is, suppose it is V1, and radius of curvature, we have two radius of curvature. If C1 is the center of curvature, R1 is the radius of curvature. If C2 is the center of curvature, R2 is the radius of curvature. So we get two center of curvature, C1, C2, two radius of curvature, R1, R2. All the distances are measured from P. Now the derivation part. Okay, so here I have written that in surface S1, refraction is taking place from rarer to denser medium. Whatever I told you, that's what is written here, from rarer to denser medium. I already told you for surface S1. Okay, so if it is from rarer to denser medium and the surface is a convex surface, then what is the formula? This was the formula, I think you remember, already we discussed the 5 cases. Okay, so this is the formula when refraction takes place from rarer to denser medium. Now this is given equation number 1. Why this is V1? Because when we considered surface 1, I was not there only. We considered that the image will be formed at I1, right? So I1 means what is the distance? V1. So that means image distance will be V1. So mu2 by V1 minus mu1 by U. U is object distance, object is there only. Okay, next, for surface S2. For surface S2, refraction is taking place from denser to rarer medium, because I1, the imaginary position, we considered it in which medium? Denser medium, because when this surface is there, if you extend, this falls in the denser medium. And finally, when this surface is present, finally we are getting the image in rarer medium. Okay, so that means here the refraction is taking place from denser to rarer medium, and for denser to rarer medium, this was the formula. If you remember the last two cases, case 4 and case 5, we got this kind of formula. But yes, there it was mu1 by u v minus mu2 by u, it was u. But here I have written v1, because for the second surface, already I told you, I1 is the object position. So if I1 is the object position, what is the object distance? V1. So that is why in place of u, what I have written? V1. Rest thing is same. This is given equation number 2. Then let us add 1 and 2. When we add it, see, mu2 by v1, mu2 by v1 negative, it will get cancelled. What we will have then? Minus mu1 by u, this one, plus mu1 by v, and this side we have this plus this. Alright, next step. So in next step, we are taking common. This mu1 is taking common here. We are taking common, so this will be 1 by v minus 1 by u. This side what we did is, this was mu1 minus mu2, I made it mu2 minus mu1 by giving one negative sign here. Same thing. So this will remain as it is. Here mu2 minus mu1 is taken common, so we will get this. Okay. Now this mu1 I am taking this side, so it will be divided, right? So mu2 by mu1 minus mu1 by mu1 means it is 1. Now remember that 1 by v minus 1 by u is equal to 1 by f. This is the lens formula, thin lens formula. In class 10 you got this one. 1 by v minus 1 by u equals to 1 by f. Mu2 by mu1 we can write it like this, mu21. Okay, this is the refractive index of medium 2 with respect to medium 1. Minus 1, and this will be 1 by r1 minus 1 by r2. So this is lens maker's formula. Very important thing, because we will solve some sums related to this formula. One example, one sum I have solved here. You can see that a lens is made up of a material of refractive index 1.5. Alright, just a second. Okay, if radius of curvature of its both surfaces are 25 centimeter, find focal length. You have to find out focal length, means this f you have to find out. Then this is the refractive index of what? Of the lens. So of the lens means here mu2 was the refractive index of the lens, so that means mu2 is 1.5. Then two cases are mentioned here. In one case the lens is placed in air, so if it is placed in air, mu1 will be the refractive index of air, which is 1 in the first case. r1 r2 is same. Suppose it is given both the surfaces are having a value of radius of curvature which is 25 centimeter, so both are same. Then next case, in case number 2, it is placed in an oil of refractive index 2. This time in the second case, the lens is not in air but the lens is dipped, it is inserted in oil. The oil is having how much refractive index? 2. So in the next case mu1 will be 2, mu2 will remain same. This is the refractive index of the lens, which is 1.5. okay, so in this way we will solve this sum. First case, lens maker's formula, mu2 is 1.5, mu1 is in, this is the refractive index of air, so it is 1. r1 is this, r2 is this. Yes, r2 is minus 25, because if you remember the diagram, it was like this. r1, it is this side, no? c1 was somewhere here, and this distance was r1, so it is towards right. Towards right means we consider it as positive. r2 was for the next surface, so for next surface this was the center of curvature and it was towards the left. So if it is towards left, r2 will be minus 25. If one is 25, the other one is minus 25. So we'll substitute here 1 by 25, then minus is there in the formula, then minus 25. If you do this calculation, the value comes as 1 by 25. This is f dash. F dash means focal length in air, suppose I have written. Okay, then this will also be f dash. So f dash equals to reciprocal, it will be 25 centimeter. Alright. Another thing you remember, that since the focal length is obtained positive, that means when the lens is in air, it behaves like a converging lens. If the focal length is positive, the nature is converging. If the focal length comes as negative, the nature is diverging. Let us see the next case. In the next case, what are the changes? This part will remain same only, just like this. Okay, only change will come here, because it is this time it is dipped or it is inserted in a liquid, in oil. The refractive index is 2, so mu1 will be 2. If you do the calculation, 2 1.5 minus 2, so the value comes as negative, right? You can try the calculation. The value comes as negative, and this is same with the previous one, this part. So if you do the calculation, finally we are getting f equals to minus 50 centimeter. So already I told you that the lens, if the focal length comes as negative, the lens is behaving as a diverging lens. But see, generally convex lens is a converging lens when it is kept in air. But as soon as you are keeping the convex lens in oil, whose refractive index is more than the refractive index of the material of the lens, which is 1.5, then the whole thing, the lens, it is behaving like a diverging lens. Okay, very important thing to remember. There may be few conceptual questions also related to this formula. So this one you remember, that when it behaves like converging and when it behaves like diverging. Thank you.